Hi everyone, and welcome to this machine learning tutorial. Today I'm going to discuss the logistic regression, so let's get started. So we all know simple linear regression, and we know that it comprises of an equation which has its independent variables and produces our dependent variable. So in this example, we have a simple linear regression in which we only have one independent variable, which as a result will produce our corresponding output. So in this example, we have the experience on our x-axis, which is our independent variable, and the salary in terms of dollars on our y-axis. And you have the algorithm which has constructed its equation in order to take different sets of years, which, for example, you can put the x here as 0, 1, 2, 3, and as a result produce its corresponding output. And you can see that here the algorithm has tried as much as it can to fit this linear regression or this line on the data set which is scattered on the x and y axis. And the linear regression, whether it's simple or multiple linear regression, I'll try to explain further in other videos. However, the scope of this video focuses on the logistic regression. So here, I am giving you just a quick and brief illustration of linear regression because we can't really use it in the next challenge that I'm going to show you here. Imagine if your points are scattered in that way. So you have the points scattered on the x and y axis where the values are either 0 or 1. So you have a dichotomous output. And dichotomous, I mean that you have two outputs of classes, or your data belongs to this or that, either way. So here, imagine if you have a business case, and in that particular business case, a company is sending email advertisements to its subscribers or its clients. And anyway, it tries to predict whether an age group will indeed respond to its email advertisement or not. So this is one example of using logistic regression in order to deal with this business case. So as a result, we have the age on the x-axis and the ad response, whether our certain client or our subscriber did indeed interact with our advertisement or not, or whether he or she was interested in previewing further info about the service or the product that we are offering, and so on. It can be used in many business cases in which you're trying to predict whether this person belongs to a certain class or not. So here we just have two classes, yes or no. And the no here is encoded as 0 and the 1 is encoded as yes. And you can see that the data points are scattered in this way, which makes it rather challenging to apply linear regression on this data. So I'll try to break it down as much as I can to how the logistic regression tries to approach this simple or this challenge that we have here. So let's try to understand the way our points are scattered. Our data set is exhibiting some form or some kind of pattern. We can see here, as you can notice, that whenever the age of a person increases, there is a high chance that they will actually respond to an advertisement. And the opposite is also true. As the age of a person is lower, you can see that there is lower chances of being or actually responding to this advertisement that the company is sending. So it's some kind of trend. Logistic regression here produces probabilities. And what it does is that its probabilities ranges from a set of numbers in which it can range from 0 till 1. So these are the two numbers that the output is ranged between. However, here in our points that are scattered, we only have 0 or 1. And this is because we actually do have our training data set. We know if they have responded or not. We have a set of sample of data in which we're able to recognize or say whether, yes, this user has actually clicked on my ad or not. So obviously it's going to be on 0 or 1. However, on new predictions or new set of instances of new clients, for example, I don't think that it will highly or most probably be on 0 or 1. We here produce, or here the algorithm produces probabilities, meaning that it can utilize the space, as you can see here, in the middle to also tell you the chances or most likely how this person or this client will interact with your advertisement. So you can have chances of 0.5, or there is a chance of 75%, 50%, 80% that they will actually be able to subscribe or interact with your products. So here, as you can see, this is what logistic regression does. So it kind of makes sense. It makes sense that it's going to be scattered, or the points or our new predictions can range between 0 and 1. However, what it tries to, or here the algorithm tries to enhance, is that part, these two parts, the one below 0 and the one, above 1. Because, above 1, you're actually also saying that there is chances more than 100% that they will subscribe or they will interact with your advertisement. So it's like saying that they will interact with your advertisement. So why not allow the algorithm to say that anything above 1 means that it's going to be equal to 1, or there is 100% chances that they will interact with your ad. So there is, it's illogical to say to produce values above 1, saying that there is more than 100% chance. No, it's 100%, meaning that I am sure that they will actually interact with my product. And the same applies to below than 0. It makes no sense to say there is a negative 0.5 or negative 50% that they will actually not interact with your product. So this makes me certain that they actually won't interact or click on the advertisement. So why not allow it also to be the minimum result or the minimum output to be 0? That's why the algorithm allows its output to range from 0 to 1. So you can see here that the algorithm was fit to our scattered data points to exhibit or in the following form. Okay? And the probability here, we give it an annotation of y hat. This is the predicted probability. For example, let's say that years 50 and older, this will actually allow my customers, or I am certain that they will interact with my ad. And here it also says that from ages of 30 and below, I am certain that my customers will not be interested in that particular product or in my particular offer. And from here, let's get into the math. How we allowed our data or our model to fit on our data set is that we have our linear regression equation. And we have a sigmoid function. The sigmoid function actually is responsible or allows the output, the range of output to be between 0 and 1. So it is responsible for actually producing my range of probabilities. So I want to do two things. For a person who isn't really interested in the math, I'll try to make it as simple as possible. So what here I'm trying to do is that I want to do two things. I want to fit a line on my data points, and at the same time, I want my output data points or my output predictions to be probabilities ranging from 0 to 1. So what happens is that I apply the sigmoid function on the linear regression. So here, after lots of this is the sigmoid function, getting the p, which stands here for the probability on the left-hand side, and everything else on the right-hand side from the equal sign. I here allow the linear regression, which is here y is equal to all of this. I substitute the y, e to the power of negative y, so this negative y, or the y itself, is substituted by this whole equation, and as a result you have this following function. Okay, and this is fitting the sigmoid function on the linear regression for the purposes of actually producing a line that fits our data set and at the same time producing probabilities. So as you can see here, I have transformed, or I have fit my line on the data points as they should. So at the end, we know that logistic regression, when it takes any value of x, 20, 30, 40, 50, what it does is that it produces a set of probabilities. Your p hat can be 23%, 85%, 99.4%. So this is what our logistic regression does. It tries to classify our data points to be whether it's going to produce a high probability, or is it more likely that particular instance is going to take an action or not. So it also can produce two classes and more than two classes. So this is basically what logistic regression tries to do. And also, before I forget, a lot of people do not want probabilities. They want an estimate. For example, you can say that probabilities, if I have an output of a probability of 0.5 and below, project these to be as 0. Okay, so I will consider them to be as if the customer hasn't really or will not likely respond to my email advertisement. However, if it's above 0.5, then there is a high probability that they will subscribe or they will interact with my advertisement. So some people encode outputs 0.5 and less to 0 as if they are not likely to respond to my advertisement. And values above the 0.5 can be greater than or higher than 0.5 can be encoded as 1. So there is a way also to encode your values into definite classes of 0 and 1. And it depends on your business or the business case and how you're going to produce your estimates. So this was the ending of this machine learning tutorial. And in the next tutorial, I'll try to get into more math. This is actually going to be mostly math about how the coefficients of the logistic regression are deduced. And the concept that we're going to describe is the maximum likelihood estimate. So I hope you understand. So please like this video and subscribe to my channel.